Malawi cichlids produce a massive amount of physical waste. In a crowded tank, their constant activity kicks up debris, creating a high bioload environment that requires heavy-duty filtration. Looking at a tank this volatile, it is logical to assume you need a complex, motorized canister filter to keep the water clear and safe. Yet, many expert breeders skip the high-tech hardware. They rely on a simple block of foam sitting in the corner of the tank to handle the mess. This works because of how we define filtration. Mechanical filtration is the physical trapping of solid debris, like fish waste, within the pores of a material. While chemical filtration absorbs dissolved toxins, biological filtration uses live bacteria to neutralize waste. Beginners often assume the sponge is limited to that first mechanical step. Dismissing the sponge as a simple debris trap overlooks its primary function as the tank's most efficient site for bacterial activity. At a microscopic level, this open-cell film provides a massive amount of surface area for beneficial bacteria to colonize. These colonies drive the nitrogen cycle, the process that prevents fish waste from turning the water toxic. Decaying waste releases ammonia, a highly lethal compound. Sponge bacteria consume this ammonia, converting it into nitrite, which is still dangerous. A second bacterial strain processes this into nitrate, a safe product that remains until your next water change. An air pump pushes bubbles up the central tube, creating a vertical draft that pulls water through the sponge walls, without a motorized impeller. This constant surface agitation provides the high levels of dissolved oxygen the aerobic bacteria need to multiply and process waste. This makes the sponge filter a specialized oxygen delivery system that maintains the specific conditions required for a large bacterial colony. To see how this biological engine scales, we can look back at the extreme bioload of a cichlid tank. Powerful motorized filters often create narrow, violent jet streams. This leaves dead spots in the corners of the aquarium, where waste settles and rots, bypassing the filter entirely. Experts solve this by adding a curved tube to the airlift. This directs water out horizontally, creating a slow, circular flow pattern that moves the entire tank volume. This horizontal movement keeps heavy waste suspended in the water column, ensuring it eventually passes through the sponge to be processed by bacteria. This circulation also pushes oxygenated water down into the substrate. It effectively turns the gravel bed into an extension of the filter, providing even more surface area for bacteria to neutralize waste. By controlling the direction of the flow, a single sponge filter can utilize the entire aquarium environment to maintain water stability. However, the stability of this system depends entirely on how it is maintained. Many hobbyists accidentally kill their bacterial colonies during routine cleaning. To clean the filter safely, you must slide a plastic bag over the sponge while it is still underwater. This prevents the trapped debris from flushing back into the aquarium the moment the sponge breaks the water's surface. Once the sponge is out, the most common mistake is rinsing it under a tap to make it look brand new. Tap water contains chlorine or chloramines used for disinfection. This chemically sterilizes the sponge, wiping out the bacterial population and causing the nitrogen cycle to collapse. The correct method is to squeeze the sponge inside a bucket of old aquarium water. This removes the physical sludge, but leaves the bacteria intact. Success with a sponge filter requires a change in perspective. You aren't just cleaning a piece of equipment. You are maintaining a habitat for the bacteria that keep your fish alive. To see how you can establish a healthy bacterial colony in a new filter in just 7 days, watch our guide on speed cycling. Don't forget to subscribe to help your aquarium thrive.